All right, welcome to this tutorial. This is like a continuation from the recent one. We're actually doing test-driven development for smart contract with Solidity, So, and in the last class, we discussed about, or I showed you how to do test-driven development with hard hat. But now in this tutorial, I want to teach you how to do that with Truffle. I believe that for you to make a rounded Web3 developer, you gotta know Truffle and hard hat. It's kind of really important. Okay, so if you're ready for this tutorial, I would like you to smash that like and subscribe button and hit that notification bell. And once you do that, then you can jump into the game. Do test-driven development is a Web3 shop. Okay, I've actually created this smart contract that enables you to uh, you know create products, update, delete, and actually create orders, be able to deliver all those items. You know how an e-commerce application works, but this time around it's not like regular e-commerce platform. This time around it's like a Web3 version. So I built it with Solidity, and I want to teach you how to do that using Truffle framework. So we're going to code this smart contract, we're going to test it, and we're going to simulate the purchase experience so that you can see how you can actually interact with your smart contract using Web3.js and just hard hat under the hood. So sorry, Truffle, not hard hat. Okay, and when you watch the recent video on hard hat and then you compare it with this on Truffle, then you can actually come up with your favorite framework for writing your Solidity smart contracts. So with that said, let's jump into the tutorial. Okay, I've gone ahead and actually populated this with the bare bone things that we normally use. So this is just your license identifier, and this is your Solidity range of compiler authorized to compile the smart contract. So with that done, I normally start my smart contract by modeling the data that I would like to be using. Okay, and a good way of modeling data is using structs and enum. So I'm going to show you how to do all that in this tutorial. All right, so let's begin. So we want to create an enum for, call it order enum. Basically what it does is to take record of some starting status of an order, because an order can be placed, an order can be delivered, an order can be cancelled, and an order could be refunded. All right, so those are different status of an enum, of the enum that we want to create for our order. We want to create a product struct. We start with the keyword struct. Okay, what it does is actually to model what a product is. So product struct. A product has an ID, of course, and we represent that with unsigned integer. It has a string. I'm going to call this string SKU. Okay, and it's going to have an address. This address is what the seller of this item or whomever created this item. We're going to have a string representing the name of this product. We're going to have another string representing the image URL of this product, and we have another one for describing this product. So this is the description of this product, and we're going to have, of course, a price. So it's going to be on an unsigned integer. We're going to need a timestamp, okay, for taking note of the time that the product was created, and then this key is going to be called deleted. Okay, it's a boolean key, returns true or false if this product is deleted, and then this is stop to keep track of the total number of or the quantity of this product that is available for purchase. Not only that, we also have another structure, and this is going to be called Otherstruct. What it does is to model the data requirement of every order that's going to be placed on this platform. So an order, of course, will have a product ID. It's going to have its own ID, of course. Let me just do this faster. Okay, it's going to have its own ID as well. It's going to have an SKU. So this SKU will be copied down from the product that is being worked on. The name is going to be copied down from the product as well, and the image, of course, is going to also be copied down from the product that is being placed as an order here. Going to have an address that will bear the buyer of this product, and the seller is also needed. Okay, and we're going to require that they specify the quantity of this item, the total cost of this item. We're going to need the quantity and the total basically are going to be unsigned integers. So we're going to need a timestamp. All right, timestamp, which will indicate the time that this particular order was placed, and we're going to need a destination. Where is this product going? Okay, so that is the destination, and also we need another string for the phone number. So this is basically the phone number that is going to be contacted once this product is at the point of delivery. And we use our order enum here to specify the status of this order. Okay, so those are what we need to model an order. We need another struct for this. Is going to be called cat struct. Okay, so what do we need there? We need an unsigned integer for an ID. So the ID, and then unsigned integer for the quantity. So basically, when we want to submit, like place an order, this is going to be like a model of what we use in placing an order. We need the ID of the product that we want to place an order on, and we need the quantity of that product. So this kind of models what we need exactly for that, and you will see why this is important in a moment now. Okay, so we need another structure for buyer. Call it buyer struct, and the buyer needs an address, of course. So this is the buyer, and this is the price. Okay, and the quantity and the timestamp. So these are like the information about a person that purchased a product. Okay, also we need another structure. Yeah, this has a lot of structure, but I just wanted this to be like a real project, because this is actually a real project that I've already created, and I'm going to show you a demo of it in a moment. Hope the demo online is working out great. So now this is going to be called shop struct, because this is going to hold information about what is going on in the shop. Okay, we want to know how many total number of products that we have. Want to know other information such as total number of orders that have been placed on our shop. Want to know total number of sellers that we have in this store. We want to know total number of sales that have been made in this store, and total number of pays. Okay, that is paid out money, and the current balance, okay, in this store. So we want all this information, and now with all this information captured, the next thing I want to do is we want to publicly show who the owner of this smart contract is, which actually the shop account, we can say, okay, I want to create using this shop struct to create a public key, a public state variable that we will hold the statistics of this particular shop. Okay, so this shop here is going to hold the statistics of all this information. Okay, so now I'm not going to type out all these things. I'm going to facilitate this so that it will be faster for the both of us. So I'm going to just show you a few things and then paste the rest of it. Okay, so we need shop struct, we need all right, for the benefit of that, let me just go ahead with you and make it smooth for everybody. So we have unsigned integer. This is a public variable, and this is going to be called fee. So this is the amount of money basically that the store will charge per each product that is created in this store. So now this is what product array. Okay, it's going to hold all the products that we have in this store, and now we have some mappings. Okay, and this first map is going to map an address to what a product, so we can be able to know the product of a particular user. So products of a particular seller, it will list out all the seller's products. So we have another one called unsigned integer mapped to what Otherstruct, and this is going to be called orders of. So we use it to map out all the orders of a particular individual in this platform. We have another one called this is going to be address mapped to shop start. Okay, shop struct. Okay, so this is going to be like start of. It's going to be public, of course, because we want to access it. Public, so it's going to be the statistics stats of a particular individual or buyer on the platform, or the seller, whatever. So we have another one called unsigned integer. Okay, this is not the most important part. The most important part is to be able to test out this item, because test out this smart contract, because this is a real deal for this particular tutorial here. So we say this is going to be bias of. So we use this to track the bias of a particular product. Okay, so call this bias of. So for a person, for all those that purchase this particular product to be added to this, and we have another mapping. Okay, we'll call this unsigned integer. Okay, and this is a boolean key, of course. It's going to be public, and we use this to find out if a product exists. Okay, product exists. That is what we use it for. And then we have a mapping, another mapping. This is basically a two-dimensional mapping right here. I know that this mapping could be confusing for people, but this is basically two-dimensional. It's more like a two-dimensional array, associative array. So what is happening is that for every product, I want to I want to do another mapping inside. Okay, and I want to map if that order for every product, and for every orders that have been placed in it. I want to know if I want to know if that particular order exists. Okay, order exists for this product already or not. So that is why that is necessary. Okay, for the rest of this, let us paste out some essential thing, and I'll just explain that, and you can just type it out yourself. So this is an event that will be emitted. This is sales event. So this event will be emitted whenever an order was created in this platform. So it's going to capture the ID of that product, the buyer of that product, the seller of that product, the price of that product, and the time that product was actually that this sale actually happened. Okay, and this is a constructor function. What this constructor does is, at the time of deployment, it makes whomever deploy that particular smart contract the owner of it, and then the assigned fee that comes, with that deployed smart contract is then put in this place. So that is the essence for this particular fee here and this owner here. So those state variable, we take hold of this, this information coming from the parameters. Okay, now we want to create a function. Okay, let me copy this part, paste it here. So this is the function that we're creating. So this function basically will create a product for us. Okay, that's what it's called, create product, and it's going to take the SKU of the product, which is going to be like a random string that is generated from the front end, and it's going to take the name of the product, it's going to take the description and the image URL, the price, and the stock. So you specify this. This is going to be coming from a DApp or whatever you're doing with it, and we're making this public, of course, and it's payable. So we want to make sure that each time a product is listed on this platform, the owner of such product or the seller must pay a certain fee, which is where we get this fee. This fee we specified here. So this particular seller must pay the fee before being able to create a product on our platform. So now let me just bring in this requirement that we need before being able to successfully create a product in our platform. First of all, we want to make sure that how much that the seller of a product is required to pay for that product as a fee, is equivalent to the fee that we specified. So the owner won't just come and specify a fee that is lower than what we initially set out to be the fee that we charge per creation of a product. So if that fails, we want to say insufficient fund, and we want to make sure that the values that are being supplied as the SKU are not empty string, including for the name, the description, and the image URL. We want them to not be empty. Otherwise, you say that these data are empty, and we don't want the price to be less than 0, and we don't want the stock to be less than 0 as well. So we're setting out all these necessary parameters to ensure that people don't supply invalid credentials, invalid data. Okay, so the next thing we want to do afterward is to come here and actually define this particular product to now be in existence. Okay, so we're saying this product is now existing. Okay, is existing. So we specify that by what? The product number, because we access these statistics and then the products. Okay, which is what we got here. Here, this shop starts. Okay, by default it's going to be 0 because we are using an unsigned integer, and then as you increment it, you start growing from 0 to whatever positive number that we specify. So basically we're saying that product at 0 existence is now equal to what? True. Here, statistics of this sender or whomever is creating this product is now incremented, or his number of products is now incremented by 1. That is this. That is what we find out with this plus here. So we're just incrementing his total number of of products to be 1, and we're incrementing the total number of sellers on this platform to be 1. All right, and now we're defining a product object so that we can start filling it up with vital information. All right, so let's come here. So what is happening? We are defining the ID of this product. Remember, this is what we are filling up here. We're filling up all this information. All right, so now what we're doing here is that the ID, we're defining it to be what? This shop start, plus 1. So shop start by default, this statistic dot start.product is 0. So at this time, I'm assigning this product ID to be 0, and afterward immediately incrementing it by 1, so that the next time this operation occurs is going to be, the ID is going to be 1. That is what I'm actually doing here. That is why you have this plus plus behind it. It's because this is going to be assigned first to this, and then what? This is going to be incremented. Now I'm assigning the product SKU that comes from the parameter above here, including the sender or the seller of this particular product is going to be whomever is selling, is calling this function that is indicated with msg.sender, and this is the name, this is the image URL, this is the description, the price, the stock. All these things are coming from the parameters here, and then the timestamp is actually coming from the global variable of blog.timestamp. All right, and afterward, on completion of this function, we want to actually push that product into that product array which we define here. Okay, we are putting that product in this array so that it can be held here, and we're just saying return true, which is what we say that this function returns a Boolean value at the end of its operation. All right, so that is what you get for the create product function. So let's create the next set of product faster. So I'm going to create this one. This is called update product. So basically it takes just around the same thing that the create product takes, but with extra one, which is the ID. We use that in targeting who owns, in doing a whole lot of things like in targeting the product that we want to update. So now I'm going to check for some requirements. I'm making sure here that the owner or the original creator of this product is actually the one trying to update this product. Otherwise, you say unauthorized personnel. And then we take in the same set of information. Okay, and afterward, we created a product object again and then updated it with these new values that we're pasting here. After we updated the new values, we now picked out that product and updated it with these new values that we just added here. Okay, I could see that this particular place is not really necessary though. Okay, so but I'm just going to leave it there for the benefit of doubt, so because it doesn't really make any difference. So, and then we're creating this function called update order details. Okay, this function is necessary, okay, if this product right here has already been purchased by so many people. So we use this function to make sure that the change of information about this product reflects in those other places, or that have utilized information about this product. So we're just spreading out that update across our platform. All right, so that is it for this update function. Now for this function update order details, so what we're doing, we're taking a particular product, okay, and then we're looping through all the orders that there are for this particular product. All the orders there are for this particular product, all the orders, all the people that have purchased this particular product, that is what is happening here, which is an array in the first place, because you can see here orders of, so this is an array. So all the orders that have been made are being placed in this place here. So now I'm coming here to say that orders of of all the orders that have been placed for this particular item. So I'm getting the length of the array. So that is how much time I'm going to do the looping, the iterations, the repetitive task. Okay, I'm going to go create, extract each one of those orders, and then change the name and change the image URL and actually update it back with it. So that's just what I'm doing for that particular function. It's something really simple. All right. Next, I'm creating this particular function. that enables me to delete a product. So it takes a product ID and ensures that the person that is trying to delete this product is the owner of the product. And then once that is fulfilled, it deletes it by toggling the key to what deleted to be true, and then returns true at the end of its execution. I'm going to copy these two functions. This function gets all the products, a particular product, okay, by its ID. So by this ID, I check, first of all, we must check if this product exists or not, okay, because if the product doesn't exist, it's going to say that product not found, okay, otherwise just returns that product by fetching it by its ID. Remember that arrays are indexed from 0, so that's why we maintain that ID structures to start from 0 and not actually starting from 1. Okay, so, and this other function here returns all the products in this platform, okay, all the products on this platform. We're returning it using this method here. We're saying that this is an array, so it's going to return an array of what? Product structure, which is stored in memory basically, which will be stored in the memory. But this one actually returns a single. This returns multiple. Okay, that's the difference between these two methodology of querying for products here. Now let's create another function. This function is called create order. This create order, this function takes in about 4 parameters: the phone number of the person that is going to receive this, the phone number of the person that is going to receive this order, and the destination, the IDs of the products that is intended to be what? Purchased. So if I want to purchase mango and salad, so I just target their IDs and then and specify the quantities for each one of those products as well. So these are the information that we need to create an order. Nextly, we do some validation. This total cost is a function that basically what it does is to receive the IDs and the quantity, and calculates the cost that it would take the cost that the buyer of this product will be required to pay for this number of products and their quantities. Okay, so, and we're making sure that destination and the phone number strings are not left empty. All right, so afterward, we make sure that the balance in our store, okay, in our entire shop, is populated with this total cost that we just did here. Total cost is what is being held in the balance, because we don't want to release this money to the seller until he delivers his product. Okay, so until the product is delivered, we don't want any form of we don't want the buyer, basically, we don't want to release the money to the seller. That's what we want to do here. All right, afterward, we want to perform a looping statement here for every one of those IDs, okay, this is an array. Okay, take note of this. Okay, so for the length of for the number of product that we want to purchase, we want to look through and create order for each one of them. And before we create an order, we want to check, okay, does this product exist, and does this product have enough item in stock? Okay, because we don't want to want to make sure that we're selling it only the stock, the quantity that we have is going to be sold to anybody, and we don't want to jeopardize anybody's purchase experience. So if we don't have that much of items in that stock for that product, then you should not proceed with creating orders for that one. All right, Otherwise, if this condition is met, you should go ahead and what? Reduce the stock by that quantity and assign, increment the orders of this particular, buyer for record keeping sake, and also increment the total number of orders that have been created in this store, yet still for record keeping. Okay, and after doing that, let us now create this order. So we're creating an order object here, and then we're assigning value to that order, such as the ID, the product ID, which is gotten by accessing the products here, and the order ID, which basically is the length of this ID. Okay, because each time that we create an order for this product, the total number of orders in that array keep on increasing. So each time this is done, we are actually taking we are accessing the length, because the length keeps growing faster and faster, and as it keeps growing faster, we want to what? Update that information. We want to keep on incrementing it for every loop, every time we're actually looping. So what we mean is that, once this is created, okay, the next time that this length is accessed is going to be what? Larger than this first time that it was used. So that is just the idea about it. So we are accessing the SKU of that product and giving it to the order, the buyer, the seller, the name of the product, the image URL, the quantity, the total numbers, and the timestamp, the destination and image, and the phone number. All of these things are what captured in this order here. So afterward, the next thing we want to do is to make sure that what? The orders of this, we push this order to what? The order of that is what is responsible for making this, this particular place grow faster at each time that what? An order is pushed into what? The orders of this product. It grows by what? 1. All right. So, and then we actually mark this order as exist. Okay. And this is where we emit the word information. We emit a sale, because this is actually a sales event. When an order is created, it's actually a sales event. Okay, so we set up that to make sure that we track the order ID, the buyer, who is the buyer of this order, who is the seller of it, the total number, the total, what is the cost, total cost for this particular order, and then a timestamp. All those things are gotten from this particular function. This function is huge. I'm going to break it down to, shorten our view. And then at the end of the day here, I want to return what? True, as an indication that this smart contract was completed. Okay, for this place, this is a what? The function. It just goes through the array of what? IDs and what their quantity, and just get the price and return the total cost for. That is total cost that it will require to what? To purchase the quantities of items for each one of the products that are in the store. Yeah, so it just like sums up the total amount of money that you need to pay for all the orders. The order you just placed, for the products inside of it and their quantity. Okay, let me explain this function here. This is called deliver order. It takes a product ID and then the order ID. Okay, this is for the order and this is for the product. And it first of all check if this product and this order exists. All right, if it doesn't exist, it says order not exist. So afterward, we created an order object and assign the information of that order to this order object, we make sure that the person that is trying to access this, deliver this order is actually the seller. Okay, and want to make sure that the status of this order is still what is not delivered already. If it is delivered already, we say order already delivered. That is what we're seeing here. And afterward, we want to mark that status of that order as deleted, and we actually update that order so that it will stay, it will carry the new or reflect the new record. All right, this is us recalibrating the data of the store. Okay, for example, the balance of the store is being deducted. Okay, and it's being deducted. Of course, that money is going to be sent to the seller of the seller of this product. So the statistic of this of the seller of this product is increased by say the total amount of money that it required for that order, and the sales that he has made was also incremented, and the sales at the store was incremented as well. And this actually wires the money to the seller of this order of this product. Okay, so this wires the money to the seller, and afterward we actually pushed this buyer. Okay, so now I would like you to go to this test folder here and create a new test. So we'll call this shop.tests.js. So we're going to write some tests on this, and in writing a test in Truffle, the procedure is a little bit different than how you do it with with Hardhat. Okay, so write a test. First of all, you need to import the smart contract. So you say const shop is the name of the smart contract. That is variable. We're going to be storing it, and this is basically what we are importing is the artifact of the smart contract, which is basically the ABI and the bytecode. Okay, so we're going to say artifacts. No, I'm not importing it. Just want to slice it. Truffle already has all these things figured out under the hood. So we're going to require, all right, and want the shop. Okay, so we're getting the shop artifact, and what we'll do on that require here this time is basically the test framework that we're using for testing out all these functionalities of the smart contract, which is what Chai is a test framework. And in that Chai, we're actually using another require right here. What are we using? We're using Chai as promised. Okay, so what we're doing is a promise-based an enablement that we help the each test case to be like a promise. It returns a promise so that we can use that async and await function with JavaScript. And then at the end, you append it with this should. Okay, because this is what we're going to be using should to run all the tests. So everything is going to be chained with should. Okay, for running this test, which is pretty cool. Okay, unlike the other expect that I have to wrap things around with expect, wrapping things around with expect, this is just going to be chained. Everything is going to be chained with what? Should. So all the tests are going to be chained. Okay, I want to write a function called toWe. Okay, it's going to be very helpful for us to convert a number into what? Their equivalent in what? In we. Okay, so say toWe. All right, and we pass in that number. That number we say to string. Okay, because don't convert it to string, screams out an error. So you always want to convert all these values to string. Make sure that this is not here, we don't need it. Okay, so this is a function that we use to convert numbers to what their equivalents to in we, which is a smaller denomination of what the Ethereum currency. And then once you do that, you put this your describe function, which is like a block, and this describe is going to be like the mother, wrapper for all the test cases that we're going to write, including the parameters that we're going to be utilizing in this. Okay, so I'm just going to copy down some certain variables that we created. I'm not this come here, copy down some of these things to facilitate the work. Okay, so here are some of the variables that we're creating. So right now I'm creating a variable named contract and result. Contract is going to hold the smart contract, result is going to hold the result for each iteration. So I'm just modeling how the various status are going to be, and this is their right orders. And yes, I'm going to remove this wrong ID. So this is the ID of a product that is created. The first product I'm going to create is going to have an ID of 0. This is an SKU. Let's say this is a randomly generated string, and this is the name of the product, which is a games console. This is the updated product. So let's say Nintendo. I don't know if I spell that correct. Console. Okay, and this is the image URL. This is the new image URL. This is the description, and this is the price of this particular product. Okay, so, and these are the quantities. Okay, so let's say we have product 1, product 0, and product 1, and these are the quantities. For product 0 we have two of it, and product 3 we have 3 of it. Okay, this is destination, and this is what the phone number. This is the fee basically for the fee that it will cost for putting an item in our store. Okay, and that is very important in our case here. So yeah, so this is the fee that it's going to be costing for each product creation. Okay, and after we do that, we want to do a before. So this is called before each one of the test cases on this platform runs. There is going to be this asynchronous activity happening. What do we want to achieve here? We want to be able to grab the address, the account of the seller and the buyer. Okay, want to grab it and want to actually deploy the smart contract. Okay, so we say seller and buyer. We're destructuring the result that we're getting. The result that we're getting actually is an array. So we're going to wait for web3. Okay, .eth web3 basically is a small web3, not a large web3. It's still importing this thing automatically. So small web3. Okay, .eth.get account. Okay, this is going to return a list of accounts in array that is in this particular network that we're testing it, and this is a test network. Of course, this is a local network. So what we're using is actually Ganache. So you're going to communicate with Ganache and get the list of accounts that is available in that network. Okay, and we're going to get the first and the second one, which is what we call it by seller and buyer. And we want to specify that little icon there. For some reason it is kind of important to put I think this kind of just specify that since we are not creating like a variable name, a variable this thing called like this. Okay, so since we're not doing like this, okay, I guess you're just saying you're gonna put it this way. I don't really get the full on that, but it is very important that we put this little piece of code here. Okay, so after that one, we'll say contract now, which is coming from here. This contract, we want to what? Want to deploy the contract and actually store the result of it in this place here. So say await this shop dot new. Okay, in this new shop, we are actually deploying it with the fee. So this is the fee that it will be charged, okay, for each product creation on this platform. Okay, so with this done, the next thing we want to do now, to create a describe block. Okay, this describe block is going to work called deployment. So this deployment here, okay, in this deployment here, what we want to achieve is we want to write tests. We are grouping our tests now. We want to write tests that are only that concerns themselves with information, concerning the status of the smart contract once we have deployed it to a network. So for example, we want to be able to confirm the address of the deployer and what the tags to be what we actually supplied when we were deploying it. So this is how we do it. This is how I write the test. You say it, and then you put parentheses. And you're saying what? It should what? Confirm deployer address. Okay, this is going to be an asynchronous call. Great. And now we what? Query. We use this result variable to query the contract. I'm going to wait for it, of course. The contract dot. What were we requesting for? What we're requesting for is the owner. Okay, we want to know who the owner of this smart contract is, which is basically the deployer. So we're checking out this owner here. So we want to make sure that the owner, okay, has to be like addressed like a function basically. So I want to say result. I want to check dot should. Okay, this is where that should chaining comes in. So we're saying this this result should what? Should be equaling or to equal is to equal this seller. So because we actually used the first account is the seller's account. So when this smart contract is deployed, the very first account is always what is used for deploying the smart contract. So we're testing out, we're checking out that this particular let's say we say the buyer, and let's run this test. Okay, and to run a test, all right, in Truffle, you want to make sure that, let's clear this console. You want to make sure that the blockchain server is running. So we use Ganache, okay, CLI, all right, and I've already taught you how to install this. So if in case you're using npm, you can say npm i-g for global, and you're installing Ganache-CLI. Okay, this is the package that you're running. Just click enter, and that is it. Okay, for Mac users, you have to add sudo in front of it, if you want to install it globally. So that is just what it is about that. So when I'm saying Ganache, I've already installed that on my machine. Okay, Ganache CLI, and say -d, okay, and you run that, and then the server is started, and all the private keys are already listed out for you including the account details. Okay, and you add another, you open another terminal. This is where we start running our test. To run the test, provided that you put your test in this particular folder called test, all you need to do, come Truffle test. Okay, so in case you don't know what Truffle, how to install Truffle is basically, I've already shot videos of how to do this, so I expect that if actually gone ahead and watched the video where I actually built with Truffle and I showed how to install Truffle into your machine globally. It's basically the same way. You can use yarn npm. Okay, say npm, npm install I for install and dash t, say Truffle. Okay, so it's basically the same thing. Make sure that if you're a Mac user, you can put that sudo in front of it. All right, so this is how you do it. All right, so that is how you install Truffle on your machine globally. With that installation, you just need to do Truffle test and run it. And yep, it failed. Why did it fail? Having an issue with the smart contract. So here, this is supposed to be stats, not start. Okay, so that is why it's bringing out all those information. So basically, your smart contract is compiled, and after it's compiled, it's going to what? If it's successful, it's going to proceed with the testing. So because there was an issue with one of the state variables, kind of alerted me. So I clear this and run this test again. Okay, saying now that member total not unique after argument lookup. Sorry. Already declared. Line 35. Let's check out 35. Line 35. Okay, so we have total here in this Otherstruct, and then on line 35, 34, oh, kind of double this, so I have to remove one of these. Yeah, so that was the problem. So now let's clear this again and let's run it. Clear this and run. All right, there's another problem saying that member deliver not found. So that means that I may have typed this wrongly. So the best way of doing this is to basically just type it correctly. Okay, so I'm going to come here and replace this with this. Yeah, so let's clear that and run that again. Boom. Okay, here we go again. The web tree is not defined. So basically, I think we must have used web tree in one place. This web tree is not web tree. It basically should be a small web tree like that. Okay, so let's clear that and run it again. So string is not a function. This is supposed to be string, not sting. Yeah, and that got me sting, So now let's run that again. It kind of checked all our information to make sure. Oh, finally. All right. So now you see that test ran and it failed, basically saying it failed Why did it fail? This is the account that deployed the smart contract. This is the one that we're trying to compare it to. So they are not the same. And I know why. This is intentional. So when I pass this seller instead, which is the one I'm actually supposed to pass initially, and I run this again, okay, you see that it worked successfully. So we're validating that this is what the account that deployed the smart contract. So the next thing we want to test out in this place, we want to test out the fee here. Okay, we want to check out the fee. So we want to say that the fee is equal to this fee here. Okay, let's just say we say the fee is actually equal to 0.02. 002 is that? Yeah, this is it. So let's say should confirm, fee. To confirm the fee. So in doing that, let's run this to see if this one will pass. So when we run that, run test, Truffle test, filing. So it's saying that it failed because the fee basically that we supplied is in integer, a pure, if decimal place value. This is not what we want. So let's put it on a string. Let's see. Let's run that. So this is actually what we are supplying, and we can't use this way. We have to convert this to a string. So we say to string. Okay, the result of this fee, whenever we get it, since it's a number, we want to make sure that it's a string before we actually run it. So now let's run that test again. Okay, it's saying now, you see, this is the real value. This string is basically not the same as this. So for us to make sure that what we are trying to equate this result with is in in we. Okay, so you need to convert this to we. Okay, which the fee is already been placed in we. So if we say fee here, or we just say to we, and then we actually passed 0.002, and let's run this again. Yeah, it worked successfully. What if we change it to this fee, which is the same thing as this? So we change this to this fee and we run it. All right, so there we go. That is all we need to run for this deployment, this group of tests here. So the next thing we want to run is for creating it for products. Want to run some tests for products. So we say describe. So we say products. And then we say before each item, each test in this group runs, we want to be able to do something. What do we want to do? We want to first create a product, because before we can run any test on the product, it needs to be created first. Okay. In creating it, we're gonna do something really simple. Let me just say before you create, because it's going to be an asynchronous function, and this is what is going to happen. Let's just copy something like this. All right, so here what we're creating a product. Okay, we're querying that contract.create product, and we're passing the SKU, the name, the description, the image URL, the price, the stock. And this is the seller, the person that has the product, and this is the fee. Okay, this is the amount that the store will charge per the creation of a product. So you must take note of this. So before each one of the tests on this platform runs, this must be what? Firmly created. And then after this has been accomplished, the next thing we want to do, we want to start running some tests on it. So for example, we want to say each should confirm product creation. So we want to confirm that that product was created successfully. And in doing that, let's check. So we say await this contract or this smart contract. We want to say .get product. Get product. What we're querying is this particular, say, get product. We're querying this particular function here, and we need to pass an ID for it to return us a product. Okay, so we want to actually grab the first product, the product that was just recently created, this product that was created. We want to grab the ID. So we're passing this ID, which is actually 0, because if you come here, the ID of this is 0 here. So now that we got it, we want to what? Check out result dot what? ID. Now, okay, we want to make sure that I want to say should this result.id should to equal, or should it equal? It should equal this ID dot to string. Okay, if I pass this ID here like this, and I run this test here, okay, this second one failed because what it is being returned here is actually a string, and I'm trying to compare it with an integer, so it doesn't work. So I have to convert this particular side to string. Please take note, whenever you're working with integer values, is always safe to first of all convert it to what? Strings before you start making your comparisons. All right, so we say to string here. All right, and then we'll run that function again. All right, it passed successfully. So it's confirming that this particular ID exists. That means there is a product with this ID here. Okay, so there is a product with this what? ID. We can even go further by saying we want to check the name of this product. The name should be equal to that same name. Okay, that's the name of the product that we supply, because this is the name of the product. So we want to also confirm the name. So if we run this, it should still pass successfully. Fantastic, it passed successfully. So let's move on to test the next function. So the next function basically is our ability to what? Update a product. Product updation. I actually checked out this meaning of this word updation. Basically, it's correct. It's not a it's not tautology. It's actually how it is. It can be pronounced this way. Okay, so first, I want to grab this particular. I want to confirm that the product. I don't need this place, so I'm going to remove this ID place. So I want to grab this product that has been created, and I want to confirm, okay, the name is actually what I created it with. Now I'm going to run an update function on it. Okay, so let me copy this here. So this is await. So now I actually updated this particular product with the name, using its ID, of course, with this new name, description, this URI. I could actually say new URI. Okay, so I'm going to confirm these new things that I've just updated, if they are correct or not. So now I'm going to run this particular function again. Come here. I'm going to paste this here. I'm going to say this name now should be equal to this new name, and if that is correct, it should what? all passed successfully. But if I still keep it as name, okay, just watch what will happen. I run this test now. You see that it failed. The updated name is actually Nintendo, but the one that I used in creating it initially was what? Game console. So now I just need to pass this new name on it and run this test again. Yeah, when I ran it, you see it actually worked this time. So it is confirming that this function, this smart contract can update. So I'm doing all these tests programmatically, without me going to remix ID and be clicking on all these things one after the other. Okay, so with that done, let's check for ability to delete a product, to delete a product that we created. So we're testing out all those functions, remember? So we can just easily just duplicate this and say should confirm product deletion. So deletion is actually another name, so may want to check that out. I may be wrong, who knows, you may be right. So I first of all get this product and I want to check the status of this product, because each product has a status, and I want to make sure that the status should be equal to deleted. Okay, should be what? False by default, because I haven't deleted this thing. So originally the deleted status should be what? False. So now I can come here and actually delete this product. I don't need all this. All I just need is this here. Okay, so I actually went ahead and I deleted this product, provided that I'm actually the owner of the product. So after deleting the product, I want to confirm that this product now is not deleted. So I come here, change this to true. Okay, but before that I want to check if it still remains false. So when we run this test here, all right, see, expected it to be true, but equals false. So after you finish deleting, this thing should change to true. That is how we designed it. So when I pass this through here and run this test again, yep, it all ran successfully. It passed successfully. Please take note here that when we're dealing with Boolean value, there is no need for you to convert it to string or whatsoever. It works out of the box. It's just integers that have some glitches. Okay, so pay attention to that. When I was using Hardhat, basically I didn't need to be cautious about those string to string conversion, but with Truffle, it kind of is important. And so that will be all that we will need for ensuring that we've validated that our functions for the product are working. Okay, the next thing that I want to do is want to check out for order. So we want to be able to create order, cancel order, or delete an order. Okay, and before we can create an order, we have to have a product, right? So that is where this before an order, we need to create, before each one of these things run, we want to we want to be able to create a product before we start placing orders. Okay, so inside here I want to create another describe block. So this will be called placing Yes, you can create describe within another describe function, a describe block. So I want to say that this is called placing an order, or just say placing orders. All right, so because that is the kind of test that we're going to be running in this block. So before we place uh, a test, we want to also use this before each now, this hook again. Okay, so this hook here, for each one of them, we want to be able to create an order. So okay, this is the function that I'm running, and I want to expand this function. So first of all, I want to create an order, and what are the things I want to pass? The IDs here and the quantity. So the IDs are coming from here. These are the IDs here, and these are the quantities I want to pass. This is destination and phone number. So I come here, change all these things. Say what? These are the quantities that I would like to what? Those orders to bear, and this is what the destination. This is the destination here, and this is what the phone number. Okay. And basically I want to say to we one ether. I want to actually send one ether as what we use in purchasing each one of these items. Okay, one ether should be sufficient enough to run this test, but because we have more than one this is an array, so we want to be able to place orders for each one of these products. Okay, so we need to loop through this thing here. So I want to say for a for loop. Okay, so I'm going to pass this in here. This is where the for loop is going to be running, and you know what, this looping thing is completely unnecessary, so I'm just going to leave it here like this. Okay, so because all of these looping things are done inside for us, so we don't need to actually do this ourselves. So now, before the creation of an order, a product is created, and before the placement of an order, an order is created, and who is creating the order is actually the buyer, not the seller. Okay, so the buyer is the one actually creating or buying these items. Okay, so once that is done, the next thing is to start running some of our functions, our tests. So we say it. What does it do? It should confirm order placement. So I want to confirm that this order that we created here has been created successfully. So in order to do that, just run this fat arrow function. I want to say result is equal to this await contract. I want to get orders. Okay, and remember, this is a function here. This is a function called get orders. Look at it. It just returns all the orders that have been created in this platform. And once we get it, we want to check the size of the array. Okay, you say this result, which all the orders are going to be stored here, should, so it's not equal this time. It's not equal. This time it's actually half. This is how you use in checking the length of an array. Okay, half dot length of. So the length of this should be, because there are two IDs, so the length of it after creation should be what? 2. Okay, so 2 orders have been created. We want to test that 2 orders have been created in this platform. Okay, because each one of the product there is 1 order. So that is how it is, in this smart contract here. So want to make sure that want to get a specific order. So we want to say result, basically the same thing here, result, not get orders but get order, and this is the ID of the product, and we just want to get the first order. We don't need all of them, we just need one of it, and we're going to store it here in this result. Because it's not a constant, we can actually override it over and over instead of creating different variables. Then we want to say this result dot status. Okay, this is the status of the order. All right, should want to make sure that the status of the order should equal what? Placed. You know that we have this whole thing, placed, delivered, cancelled, and all that, but they are all complete integer, so we want to actually turn it to a string. So we say to string. Okay, or we can just turn it to a string here, which would make it a lot better. So we want to make sure that it is placed, and after that we want to also check for another thing. Let's say result is equal to await this contract again, and we're actually getting the start of the statistics of this buyer. Okay, I want to find that result dot orders. I want to find out total number of orders that this person has, to be, and of course to string, because we're dealing with integer here. Want it should to equal to, and you can notice that I'm putting it in let's put it in a pure what is it called, integer, or later we'll check it out to find out. Let's run this test to just see what is going on here. So what this test is doing is what? First, it gets the order after an order is created. So get the order, and the number of order that will be created is based upon the number of products. So we have about 2 products here, this one and this one. Okay, those are the 2 products. So that if a buyer is actually buying those 2 products, that means it's 2 orders that he's going to have. All right, so that means the length of this get orders should be what? 2. Okay, and because it is only one buyer that purchased these 2, those should, his total number of orders should be recorded as 2. That is just what we're doing, and the status of that order should be what? Placed. Okay, and the statistics of this particular buyer should reflect that he now has what? 2 orders in store. So with that said, let us run this test here. Okay, it failed with transaction return should confirm. All right, there's something going on here. So before each, in this place before each, this is where okay, I think I know why now this is misbehaving. In this place here, we want to create a for loop around here. Okay, for loop structure. The purpose of this for loop is to ensure that we have more than one product. Okay, so what I'm doing is for this I, okay, greater than the IDs the length. You know that id is what? An array. So basically, for each one of those array, for each one of those products, we want to actually create want to create them first, okay, and then want to create those products 2 times. If we have about 2 products in that array, we want to create it 2 times, and afterward then we can proceed. Okay, now surrounded this in a for loop that enables this to be what? Created 2 times. So now let's save and run this again. The recent command. Okay, seems to be working now. So when we unravel this, now this is not supposed to be 2 products anymore. Okay, let's just check it out first. Okay, so let's run the entire set of instructions there to check. Because okay, we have an error here. One of these things is saying dot to equal. This equal is not correct. It's supposed to be 1q. See that here? So let's run that again. Okay, expected what? 2. And this line 133 here. Okay, this is supposed to be a string. Okay, supposed to be a string. So except to convert it to string like this, then the basis for equating the both of them will not be established. So now let's run that test again. All right, it passed successfully. Let me re-explain this a little bit. What we're trying to do is to confirm that an order can be placed, okay? And before an order can be placed, we need to first of all what? Create, that product that you'll be making orders on. So because we have about a couple of IDs, okay, these are 2 products. So we are creating 2 products basically for each one of them. We're creating those 2 products. Fantastic. Okay, after we create it, we're now creating another describe block, and in doing so, we want to what? Before we start placing order or checking if an order can be placed, canceling order and delivering order, we need to first create the order. So we created the order here, that is this before each hook, and afterward we now created the first test here, which what we did was to confirm that this order has been placed. So we wrote this line, we grab the orders that we have, this returned a list of orders for us, and then we use this method of this should method to check for the length of the array that is being returned. If it is up to 2, because of 2 IDs here, so you should be able to return 2. Because if I increase the number of IDs there, it should then become what? 3. So because the number of IDs are 2, just like we can see here, are 2 items here, so only 2 items can be placed orders on. So that's why this works flawlessly. And now in this place, after we get the total number of the orders, we are actually grabbing the first order. Okay, grabbing order by ID. So the ID of this product is 0, and then we are getting actually the first order in that product for that product, and then we are checking the status of this product, of the order, is it placed, and it was placed, of course. And then we're getting the statistics of this buyer. I want to check the number of orders this buyer has made, and to be equal to 2, and of course it is 2. So this whole thing passed, and that is our first test. Okay, so let's create another test. All right, see, it's very easy. All you just need is to follow this sequence, this method that we're doing. Okay, this should confirm that order can be marked as delivery. can be delivered. Okay, so we want to be able to establish the fact that we can actually deliver stuff on this platform. So now step one, let's say we get this order. Of course, it's going to be placed by default. After it is placed, then we want to actually deliver the product. So we say await contract dot deliver. I'm gonna just copy the function name here. So say deliver order, and the order ID is going to be what? This ID. This is the what? The product ID. And then for which particular order, for this particular order, we want to deliver this particular order at index 0, or order with order ID of what? 0. We want to what? Want to be able to deliver this one. And of course, it's going to be coming from what? The seller. It shouldn't be coming from another person. If not, it fails. Okay, so with that done, after this, I want to what? I want to check the statistics of what? Of this seller. The statistics of this seller, and I want to check okay, before I go there, I want to first check. I want to make sure now that yes, if we come here, this should be delivered. Okay, let me just change all this to string so I won't have to come back here. So now, after delivering an item, the status of it should be changed to what? Delivered, not placed anymore. Then after that, I also want to check the status. Okay, the status of this seller. Okay, so say status of what? The seller. And we want to see that want to run on that test here. So we call this stats. Okay, so in these statistics, I want to compare that. I want to make sure that these statistics dot paid. So because if this product is delivered successfully, the paid will what? Increase, right? It will increase by this total. That is the total amount of money that order was worth. Okay, so I want to test that. I want to check the paid. Okay, of course, since it's an integer, I'm going to make sure that it's in string. Okay, the should and the to equal. Okay, it should equal what? This result here. This is result. I'm grabbing it from that specific order. So I want to get the total in that order. So result dot what? Total. Okay, this total was the total amount it took to what? Place this particular order that has now been delivered. So I'm actually what? Checking out the total that it was cost. I want to see if this paid now is equivalent to this total that particular order took. All right, so because it's only one order that has been delivered here, so the paid should only be one. So we're just testing it out here. Of course, we want it to be a string. Okay, so with this now, let's actually run this test this time and see what is going on. So we clear this and I'll run this run test. Okay, it all passed successfully. Why did it pass? let's say I remove this here and I actually run this here now. Oh, it actually, I didn't really need to convert it to string because this is already a string. What if I remove this, okay, and run this again? Okay, it failed because this is an integer. I need to be converted to what? To string. So basically it took one iter. This is what this person got. This is total cost, okay, for this particular product. This is what it cost in the quantity that it was actually purchased. This is what it should what equal. Okay, so now the page should record that it has received this. The seller has received this amount of money. That's what we are testing out for here. So I'm just going to convert it to string. Okay, and when I run that, if this is equal to this, if truly the seller has received, this amount of money, is going to be what? It's going to pass. And that is what we've just tested already. So I'm just like trying to bring that to the limelight so that you can understand what just happened there. Okay, so it passed successfully. All right, so let's check when an order is actually cancelled. Okay, I'm going to just duplicate this. Okay, say order can be cancelled. Okay, so by default it should be what? Placed. And I'm actually canceling order, not, oops, let's come back to this place. I want to cancel an order. It takes the same parameter, so I'm canceling this order. Of course, is the buyer that can what? Cancel the order, not the seller. So okay, now this should be what? Marked as what? Cancelled and not delivered. And basically that is all I need. I don't need to test this other part. So let me save that and run this test. Okay, it all passed successfully. What happened when the person that is supposed to deliver this item is a false person? Let's say is a buyer that is trying to deliver this item. Let's see what happens if this system is going to reject such thing or is going to accept it. You see, it failed. Error. Unauthorized what? Entity, because the buyer is not the one to what? Deliver the item, so it's got to be the seller. What about this? What if the seller is trying to be the one to what? To actually cancel the product? Let's see. Let's test that. So it failed. Unauthorized entity, because we programmed it is only the buyer that can actually what? Cancel an order. Okay, so with that done, those parameters are working, because when I test it out now, it should be working just fine. All right, so one more test that we need to run here. Okay, this is we want, remember, we want the updating of a product. In case we updated the product ID, we want that product updating to what? Ripple down throughout all the orders that have been created, and all the people that have purchased that particular order. Let the name of that order now reflect the new product name. So the name of the product here, and these people purchased this product, and now the owner of this product came and changed the name. in that changing of the name, let it also reflect for everybody that actually will purchase this product. Let their order now state the new name of that product. That is what we want to test for right now, and that is the last test, right? For this particular place here. So to test that, okay, we'll call it. Let's just come here, come to this product place. Okay, this particular one here, this for updating a product. Let's copy that test for updating a product and come to this place here, paste it here. So this is a test for updating a product updation. Okay, but product, let's call it product and order. Okay, so this updates both the product and the order. All right, so all this whole thing will stay the same, but for here we're not testing out, we're not doing this because basically this has already been tested in the previous one, so we're not actually running tests based on this, but we want to get the name of the order. So we want to say order. Basically, let's just copy this. This is the same way we'll get it. Let's come here. Okay, we want to get this order. After the updating, first the order, let's rename this as well. Okay, now the name of this order should actually be the same as the name of this console, which is here, right? So now let's see what happens after we finish updating it. Okay, so now this is for order, and this is not for the product. We're actually getting the name of the product that has been copied down to this order. Okay, so the name by default is accurate. Yeah. Okay, so now we updated this product's name. You can see new name and the image. So after we updated, we want to query this again and check it out. We want to find out, is the name now still the same name, or is different? Let's check it out. So when we run this test, okay, it failed because the new name is supposed to be what? Nintendo, but it's still game console, so it has to be what? New name. Okay, new name has to be the one reflecting now. So let's run this again. Okay, that was successful. All right, so and there you have it for the testing. So this actually worked. Okay, so we've been able to write test, we've been able to write all these tests and seeing how they responded. This is basically how you write tests with Truffle. Okay, and it's quite important that we saw how we use expect in Haddad, and now we're using should with with Truffle. And with this, you can be able to write any test that you want for your smart contract and programmatically test them out without you struggling redundantly entering data in Remix ID. So this is better, this is best. So for writing the simulation for this smart contract, I would like you to go to this folder called scripts here. Okay, now let's create a file. Let's call it perform sale. Okay, .js. All right, in performing sale, there are some things that will require doing. First thing first, just like this, we need to import this. Want to get the artifact of this shop smart contract, and of course I'm going to grab this as well. Okay, for converting data to and fro from. Okay, so now we have this module .export. All right, and it's equal to an asynchronous callback. They call this callback. All right, and then at the end of it, basically at the end of it, we're gonna execute this callback. function. Okay, so this is where all the test simulation is going to take place. So first thing first, I want to grab some accounts. Okay, I want to grab some accounts, and then grabbing those accounts is just, you know, something similar to this. So I'm going to grab these accounts. Okay, this is for the buyer and the seller. I need those two accounts, and I need some of these parameters as well, such as, you know, with this okay, down to this place. I want to copy these parameters, paste it here. Okay, I'm not doing any testing here, so I'm going to remove that. I'm going to keep this contract here. I'm not checking out the status, so I'm going to remove that. And okay, let's proceed. First step, to simulate the sale. Okay, we need to first deploy this smart contract. So we use contract, okay, which is this here. Now we say await this shop, okay, dot what, deployed. Okay, so in deploying this, it actually takes this particular, this is a contract migration script. Okay, this script to_deployed_contract, you can name it whatever, but you put it in this migration folders. In these migration folders, whenever you want to migrate your smart contract to a network, Truffle comes to this folder to look for some migration instructions for each one of your smart contract. And the smart contract that we are working on now is this shop, and basically we are assigning the fee. This is the cost per the fee, you know, this is a smart contract, and this is the fee. This is a parameter of this smart contract. So what do I mean by a parameter? If you come to this contract place, this shop here, and if you come to the constructor function, you see that this is a parameter called fee here. So that is why we are applying that fee in this place. In this place here, we're passing that fee here. So this is basically how you will structure it for this migration to work later on when you will run that script. It's gonna what? It's gonna go here and what? Pass in this parameter into this smart contract called shop and deploy it to the network. Then you can now start executing all these activities inside of what, that network, with interacting with the smart contract basically. All right, so you say let, all right, let's say seller, the balance of the seller is equal to await web3 dot eth dot get balance. The balance of who? The balance of this seller. Okay, I want to also do the same for the buyer. Okay, so we'll get the balance of both the seller and the balance of the buyer. Why I'm putting this thing here let is because I'm going to rewrite this thing as we go, so you can use const. All right, so with that done, we want to log out something on the console. We want to say, okay, initial balance of seller. So we want to log out the initial balance of what, the seller. Okay, and I'm going to interpolate this. I'm going to say this is going to be web3. Okay, basically, I want to actually take up a function here. This function is called from we. So it converts a value that is in we to what? Ethers. And this converts a value that is in ethers to we. Okay, so I need this particular function here. So I'm going to say from we, because the value that is going to be returned to me as the balance is going to be stated in we. So I say seller balance. So seller balance is going to be in we, and also the balance of the buyer. So I'm going to say buyer here. Okay, so I'll put /n. All right, so /n here, so that it will print on a new line. So it will log out the balance of the buyer and balance of the seller. Okay, so if I save this, no, let's just finish working on this. So afterward, I want to log out another thing on the console. I want to say seller creating a product. Okay, now let's actually create a product. In creating a product, we just need to do what we've been doing before. We just copy this particular value here, okay, and paste it here. Okay, so we're passing the SKU. Look at all this data. SKU name. We don't need new name. We don't need new URI. So okay, so we come in here, and for this quantity, I'm only going to target one product. I'm not going to target more than one product. So okay, so now I'm creating this product, okay, with this description, with this data, all right, with this fee, of course, which is the fee here. So after finish creating it, I say I want to log out something on the console. I want to say balance after creating a product. So this is the balance after creating a product. So I'm just going to copy this whole place and put it back here. Of course, I'm not going to use this let anymore. So this is going to fetch the new balance and then display it to me, and I could see the the balance is balance of seller balance the after creating products. Okay, I'm gonna do that same thing here. So this is the balance of the balance after we just created this product. Of course, there should be some deduction from the seller's account, so we want to actually monitor those things and we'll see them live going on. So after that is done, the next thing is to actually buy the product. It's time for the buyer to actually buy this product now. Okay, for the buyer to buy the product, we're going to run the same function that we used before, which is this function here. Okay, before we run that, we can say, okay, and just bring it here. We say buyer, purchasing a product. Okay, in doing that, this is how a buyer purchases a product. This ID and all this thing, the same way we've used it before. So now, after that buyer has purchased this product, we want to list out what their balance. Okay, I want to say balance of what? Balance after purchasing products. Okay, and now it's not done yet. Now we need to what? Actually deliver the product. Okay, so we come here and say seller delivering a product. Okay, delivering product. All right, so we come here and we run that particular function. There's a function for delivering a product, which is this here. Okay, so I'm gonna come here, paste that. So this will get the seller to deliver this product, and after delivering this product, we want to also check the balance afterward. Product delivery, after delivering, let's see, delivering products. Okay, so these are what makes up for this simulation that we're trying to do here. So we're trying to simulate the process of purchasing an item step by step. So how do we run this? First thing first, let's clear the screen. You need to start up your Ganache server, which is already started up here, like you can see, but I'm just going to quit this server. It's clear, so I'm going to run this server again, so it's freshly executed. Now I'm going to say, this is how you run a script. Okay, say Truffle exec. Okay, that's execute. Truffle exec scripts. Okay, go to the folder script / perform. Write it exactly how it is, perform sale.js, and then you click execute. Okay, it failed. Why did it fail? Because shop has not been deployed to the detected network. So we need to deploy this smart contract first to this network. To do that, this is what you need to do. You say Truffle migrate. You see, when you do that, it actually migrates all those files. You can see that it's invoking this migration file script here. You see this initial migration and this deploy migration. So that is what it's using to deploy this thing. Like you can see, it deploys this particular one using the parameters and all the whole things, and deploys it to the network. And now with that, we can see that it's been deployed. So now, since it's been deployed, let's now execute that script, this particular script called perform sale.js. So let's run it. Okay, so it ran successfully. Let's see how the procedure went. So this was the initial balance of the seller. It was 99.88, but just take note of this last three figure, which is 338. Okay, this is the initial one. And initial balance of this buyer is 100 ethers. Now the seller created the product. Okay, and then the balance of the product after creation, you see that it reduced from 99.88 to 99.87. So it reduced. It took about 0.1 ether or thereabout to as the fee that is required of this platform for you to create a product. Okay, so now the buyer, there's a product. Now the buyer came to purchase this product. Okay, and after purchasing it, look at the balance of the buyer. The balance of the buyer reduced by that is about 2.1 ethers. Okay, it reduced from, because this is what it takes to buy let me come here. This is what it takes to buy this one item 2 times. Okay, the quantity is 2 times. So that is why its balance came down like that, because he bought 2 of that item, 2 of that product, and this is his balance after purchasing 2 of that product. And now the seller comes here and want to actually the seller came to deliver this particular product. Okay, So to deliver this product, watch what happens here. After the product was delivered, the amount, the product was actually what was given to what? To the seller. Because look at the seller's balance here was what? That is what? 99.87. But later on, his balance went up to what? 99.88. So the money was not credited into what? His account. I don't know if you understand that, but this is what is going to happen. I'm going to come here and I'm going to bump this cost, because this is the price of this the price of the product is very small. Because it's so small, it's almost insignificant. Okay, I'm going to just change it to 1 to 5 ethers here, and let's see the price that is okay. So let's say 1 ether here. That is the price for what? This product, and this person will be purchasing it too. So let's make sure that he has about 3 ethers, sufficient enough to what? Sponsor this transaction. So in doing so, I'm going to what? Migrate this thing, but I'm going to reset it. So migrate but reset. So I'm going to compile this again, reset it, send it to the network. It is there. Now let me perform this sale again. And then the sale was what? Successful. Now this is more pronounced. So initially the buyer has about 99, the seller has about 99.77 ethers, and the buyer is what? 98.99. And you see that after creating a product or adding a product, his balance went a little bit down. You can see instead of 77, it's actually 76. And after this particular buyer bought twice of that product, his balance went down from 98 to what? 95. That is a very significant decrease in his balance. And then after the seller delivered the product, that money was released into his account, and you can see that his account went from 99.76 to what? 101.75. So this is how the simulation is happening. So with this sort of simulations and you testing out your smart contract this way, you can be sure that when you start putting this thing as a decentralized application on the internet, it will work just great. Okay, so that is how you actually run you do test-driven development with Truffle, and I hope you actually gain quite some good values from this tutorial. And if that is great, if that is true, actually smash that like and subscribe button. While I show you this, I hope that I have let's take a look at, okay, this is a testnet. Let's come to game shop. Okay, oops, I have to connect my internet connection. Okay, we have about 7 products, different people all over the world. This is the product live on the internet. This is like the game shop that you just saw. There's a whole lot of cool stuff here. Like this is, these are people that purchase. You can see buyers off right here. Okay, you can see the button to edit, because this is the account that actually purchased, bought this. You can even chat with seller. You can delete products. You can come here, finish working on this project. Food, this devil may cry. Nobody have purchased that. You can see 7 sellers. You can see 7 products. Sales. You can see okay, like when you add it to cart, your cart increases. You can see all those cool stuff. You can increase that, and you see all those things are working. So this is an app like that I built with this particular smart contract that I just showed you. Okay, so you can do something fantastic as this. I would like to challenge you to go do that. Drop your comments in the comment section, and tell me what you think about this. Do you want to see a build like this on the channel? If that is your aspiration, I would like you to smash and like that subscribe button. We're done with this particular build for the day, and I like you, I love you guys. Okay,